receding horizon way keeps me going. And I think we'll do fairly well that way. And I think we'll have higher performance solutions if we know that if we get in the known forest, we can dart through because we can optimize the trajectory all the way to the goal. We can come up with tight funnels that go right next to trees. So I think that spectrum is all there.
Yeah, so for the former, so I mean, if you're we yank different funnels out of different libraries.
Yes.
So what sort of computation requirements for that?
That's a good question. So it depends how rich the library is. I mean, so if you have, if you have static, if you have 10 static funnels that have no parameters, then it should be very simple. And then there's going to be another motion planning problem, which is sort of what we were talking about earlier, about having sort of rich parameterized libraries that you have a higher level decision making process for. You're right. So I don't know if that's going to become stick compatible, but I would hope so. Thumbsticks are pretty good, right? Yeah. I don't know about your little chip, your VLSI chip. That might be hard. But... Yes.
So the remarks you made toward the end about model identification, you said, if I understood correctly, that you were considering rational polynomial fits to the nonlinearities from the differential equation, and then building such models as well as doing stability models. I mean, it seems to me that's quite hardcore in the sense that when you think of your robotics model, there's a significant amount of structure, geometry that you're throwing away and replacing it by strings, which perhaps might mean you need high degree rational functions or other requirements.
I completely agree with you. So I would never do this for something. If the Lagrangian of the system gives me a parameterized set of equations that I can fit the parameters to, I will do that every time. That's what we actually did on the robots we had. And typically what you're left with then is fitting nonlinear friction in the joints. This is sort of the slop terms on top of the Lagrangian. In other systems, in the fluid systems, then we're not given the gift of a Lagrangian one parameter model to begin with. I think it's more natural to do black box identification. Now the fast runner is sort of a funny in between. So this leg has so much friction and ball bearings and sliding move. I actually think that's going to be the first system that looks Lagrangian that will probably make you better with black box identification. But absolutely, if the Lagrangian is a good starting point, we'll use that and not think about rational polynomials at all. That's just to capture the stuff that we don't have a good parametric guess for. Yeah.
So you do have the idea of having a component of things that is physics space and then a component data.
Absolutely. I will do whatever it takes to make it work. Yeah, no question.
For the second